Hello there everyone, and welcome to the free bonus that you have obtained from the one-on-one mentorship program that you have just signed up for. Welcome again for signing up. You're gonna love the one-on-one mentorship program, and I can't wait to get started working with you. So this is the traffic light system project that I was required to implement in C++. So let's get into it. So a bit of an overview of the project. So the requirements of the project was to simulate a traffic light system in C++ with 3 lights, which were red, yellow and green, which only one lamp could be on at a time. And this was required to use command line arguments to set the initial traffic lights and the amount of cycles that the light would display. So the concepts applied in this project include designing C++ classes with public and private attributes, implementing the classes with object-oriented principles, bitwise operators. Now, bitwise operators is something that I didn't cover in my book because it's a topic which is a bit old, I find. But you'll get a free PDF covering bitwise operators. They're pretty simple actually. If you look at the diagram on the right, that's actually showing bitwise operators. It kind of looks like a bit of algebra, but once you understand the concepts of bitwise operators and have a play around with it, they're actually not too bad. And then the fourth concept that was included was control structures, which includes if-else statements and for loops. So if-else statements in the project would be like if it's red, then it's going to go to yellow. If it's yellow, then it's going to go to green. And then the for loops would be like counting down like how many cycles it would go through. And then lastly, we have command line arguments, and that's another topic that we'll be discussing later. So the hardware of this project was that it wasn't just a software-based project. This thing was actually running on actual hardware, and this is an OUSB board that we get given to at RMIT University when you undertake engineering computing 2, because they want us to learn how to program with hardware, which is pretty good. So as you can see on the hardware, if you look down the bottom left, there are 8 LEDs, and that's where the traffic lights are going to be showcasing. And then we have like the trim pot, the JTAG interface and switches, and the motor power. But that's not really applicable to this project. So when it comes to designing the classes with public and private attributes, the thing that we have to understand here is that since we are working with hardware, it'd be pretty wise to have a private class to store the values of the ports being used, as well as the appropriate accessor functions, which could be read and written to the ports. And also a private class variables to store the current state of the traffic lights would also be a safe thing to do to implement as well, to avoid conflict issues. Because if there are conflict issues, then you're going to run into debugging issues. And you know what it's like debugging code, right? It can be a real headache. So if you look at the 2 diagrams below here, we have 2 classes here. We have the OUSB class and the traffic light class. And in the OUSB class, you can see in the private variables, we have the variables writing to the ports. And then we have in the public area of the OUSB class, we have the setup for reading and writing to the ports and running the commands. Now the good thing about the OUSB board is that it already has specific commands ready to be written to the hardware, which is pretty neat. And then if you have a look over to the traffic light class, as you can see, the lamps are private to again avoid conflict problems. And then in the public area, we have the functions where if the function's been hidden in the code, that's when it runs. So it's pretty much the blueprint of the project. So after we've designed the classes, we then implement the classes with the C++ object-oriented principles as discussed in my book. And after the classes were created, we can now implement the class functions with the object-oriented principles. And this included the use of constructors and advanced concepts like including overloading constructors for the traffic light classes. It's a pretty advanced concept, but it's covered in my book as well. So now I'm going to show you the source code of it and guide you through it. So just like how we designed it, this is the OUSB class implementation. As you can see, it's pretty neat and pretty understandable. And then we have the implementation of the class. So what we have up here is the OUSB board constructor. Now remember that you have to understand that the constructor is what sets up the project. And then we have another implementation here, and this is the OUSB command code which sends the commands to the hardware. And then we have more of the implementation code where it's actually writing it to the ports. So we have 3 ports in the hardware. So we have port A, port B, and port C. But for port A and port B, we're reading it and writing to port B. And as well as with port C, we're just reading port C. So it's pretty neat how there's all those commands ready to be sent to the ports, which are built in. And then we have the traffic light class implementation. So again, it's pretty straightforward. We have the three lamps, red, yellow, and green, and the accessor functions. So here we go. Here we have the implementation of the traffic light class. So we have the lights for when red is on. It will send a command to the board, and the command prompt will show that it's red, and then send and make sure it turns on. And it's the same with yellow. So as you can see, it's very similar code. And same thing with green. You know, if green is set, and send the value of green to the OUSB board and turn it on. And then lastly, for the last bit, because since it's a traffic light application, we wanted to change colors. So this is where we apply the control statements, where we have a switch, where we go case 1, case 2, case 3. So if it's case 1, turn green. If it's case 2, go yellow. If it's case 3, go red. Which is so the switch statement is reading the port, which is pretty handy, and seeing what color it is, and then changing it as it goes, which is pretty neat. So back to the topic of bitwise operators. So the way that the 3 lights are turned on are by setting the bits on the hardware with the help of bitwise operators, which are the lights as I showed earlier, and also as you can see down the bottom there. And the way we set the bits are sent is by using commands to the hardware with the run OUSB command function. And this can be seen in the previous code I just showed you in the traffic light class implementation code in void traffic light red on, traffic light yellow on, and traffic light green on. So now we go to control structures and command line arguments. So the control structure in the int main part of the code included the control for the command line arguments, which would control the program. If the argument entered in was 1, it would output the traffic light program. If argument 3 was set, it would run through the initial light entered in and the amount of cycles that it would run through. And then a for loop structure was used to control the amount of times that the traffic light would cycle through, as the user had to input the amount of cycles that it would go through from the command line arguments. So here we go. Here's the code for setting up the control statements and the command line arguments. So if we set it to 1, it would just be the traffic light program. If we set the arguments to 3, then it would either be, the user would either have to set red, yellow, or green. So they would have to enter in R, Y, or G, and then the user would input the amount of cycles that it would go through. And as you can see down here, we have a sleep command that will delay the lights for half a second, and then change the traffic light state to another color. So for setting up command line arguments, I'll give you a PDF on the guidelines of setting command line arguments in Visual Studio. It's pretty much what you do is you pretty much go into the project properties, debugging, and then command line arguments, and over here, see how we have G5? We can set the command line arguments right there, and then run the application. So the resources that I want to give you today for this bonus is the Bitwise operator tutorial on understanding Bitwise operators and having a play with it. How to set up and run command line arguments in this application, and I'll give you the source code of the application so you can have a play around with it. And that's all from the bonus. And I hope you have fun playing around with it, and take a look with it, and see what you can come up with and play around with.